In this video, I'm going to go over the limiting reactant worksheet B. You can see I've got the equation written up at the top. It is already balanced, and then I have the amount of each of the reactants that we are given. So we're given 25.4 grams of aluminum oxide and 10.2 grams of iron. And the first part of the question asks us to determine the limiting reactant. So we're going to have to take both of our reactants and find out how much product is made. And the next question on there asks us to determine the amount of aluminum. So in order to kind of kill two birds with one stone, I'm going to go ahead and for my first question, I'm going to go ahead and find out if I've got this much aluminum oxide. I'm going to find out how much aluminum is made. And then I'm going to use this many grams of iron and see how much aluminum is made. And whichever one is less is going to be my limiting reactant. That will also help me with answering how much aluminum will be produced, which is question number B, because I already have the answer, because the amount of aluminum produced will depend on the limiting reactant. So I'm going to go ahead, I'm going to pause it, do that work. You can see all of my steps that I take. You can try and do it on your own as well. Like I said, start with your grams. This is going to be a 3-step problem going from aluminum oxide here all the way over to aluminum, and then the second is also a 3-step problem going from iron here over to here. So pause it, see if you can do that on your own, and then come back and check with me. All right, so here is my work. You can see on my work that I start with grams of each of the different materials here, and I actually only go to moles of aluminum because I can actually compare moles of aluminum to moles of aluminum. If you took it one more step and you went to grams of aluminum, then you would have taken this number that you've got here and multiplied it by 26.98. You still would see how many grams of aluminum are made, and your limiting reactant is going to be the one that makes less. So you can see that aluminum oxide here is going to produce almost 0.5 moles of aluminum, and then with this much iron, we're going to produce only about 0.162 moles of aluminum. So I don't have enough iron here in order to make this much aluminum. I only have enough iron to make this much aluminum. So that means that the amount of aluminum that I am going to make is going to be this much aluminum, and this material, this iron right here, is going to be my limiting reactant. So that also answers letter B. How many moles of aluminum are going to be produced? Well, the number of moles of aluminum that are going to be produced is going to be 0.162 is how much aluminum in moles. Okay, so moving on to part 3, or letter C, it asks us to determine how much iron oxide is going to be produced. So the first thing to think about are what are the things that we know. From the last question, we determined that iron is our limiting reactant. So we know that all 10.2 grams of iron are going to be used. We also know that according to that, we're going to have 0.162 moles of aluminum made. So we could actually use either of those and use all of our steps to go either from this number of grams of iron used and then get to the amount of grams of iron oxide, or we could use this number here, the moles of aluminum we know are going to be produced, and we can go to the amount of iron oxide that's produced. So pause it, you can start with either one. I'm going to show my work for both of them, so then you can come back and see that you end up with the same answer. All right, so here's my work. In black, I go from my grams of iron that I've got here, and I first convert that to moles, which is that step there. I then use my mole to mole ratio, right here. I then use the molar mass of iron oxide, which is 231.5, and that tells me that I've got 14.09 grams of iron oxide that gets produced. Now, depending on your rounding, might be a little bit off, but it should be close to 14.0 something, almost 14.1. And if you look in blue, I then went ahead and did it with the amount of moles of aluminum that were calculated from part A and B on this problem. So I use my mole to mole ratio first to get to my iron oxide. Then I use the mass of iron oxide in order to get my grams of iron oxide. And you can see these two numbers are very similar to each other. So I know I did it correctly because either way, I'm going to get the same amount of iron oxide. All right, so the last question on here is asking us about how many grams of the excess reagent are going to be left. So we have to identify what the excess reagent is. So we know that we started with 25.4 grams of aluminum oxide, and we started with 10.2 grams of iron. Well, we determined in part A that our limiting reactant was going to be the iron. So if that guy limits us, that means we're going to use all of the iron in the entire reaction. So that means that the aluminum oxide, there was a lot more aluminum oxide available, but because iron is limiting our product, we're actually going to have leftover of aluminum oxide. So your excess reagent is the other reactant that is not limiting you. So that's the first thing you have to identify is what is the excess reagent. So the excess one is going to be that aluminum oxide. Now we've got a lot of information. We've already determined from all of this that we're going to use all 10.2 grams of iron, because it's limiting us, so all of it's going to be used. We've determined that there's going to be 0.162 moles of aluminum made, and we've determined that 14.09 grams of iron oxide are going to be produced, okay? We can use any of those to figure out how much aluminum oxide is going to be used up in the reaction. So I could go from my grams of iron here and find out how many grams of aluminum oxide are going to be used up. I could go from my moles of aluminum that are going to be produced and figure out how many grams of aluminum oxide are going to be used, or I could use my grams of iron oxide and find out how many grams of aluminum oxide are going to be used. So I'm going to do all three ways so that you can see the work for all three. You're going to see they come out to very similar. And then we'll talk about figuring out how much extra material is left based on our calculations here of how many grams are going to actually be used in the chemical reaction. All right, so you can see all of my work for all three different ways, and you can see that the amount of aluminum oxide that's going to be used is very similar to each other. So we were given 25.4 grams of aluminum oxide, but according to our calculations, we're only going to use about 8.26, 8.28 grams of that aluminum oxide. So we need to figure out how much aluminum oxide is going to be left over. Because remember, iron's the limiting reagent. We're going to use all of that 10.2 grams. Aluminum oxide, we're going to have some leftovers. So we subtract, because according to these calculations, we're going to use 8.27 grams. And so we're going to have about 17.1-ish grams of aluminum oxide left over. And that's it.